Hi everyone, it's Will Tonner here, sound designer and audio programmer for Lamp8 Audio. And following on from our last video, today we're going to look at mapping the third person character asset that's found in the Unity standard assets package. We're going to map those that prefab directly to Wwise, as opposed to using the standard Unity audio engine. So we're going to look at three basic elements you'd expect in a typical sound bank for a third-party character. The first of which is a basic jump sound for the respective jumping action. The second is a footstep mechanic, and we'll use a switch group within Wwise to reflect the material that the player is moving on. And the third is a modifier for those footstep sounds for when the player is crouching, using a crouch state group. So let's jump straight ahead. So, as with all videos, we're going to kick it off in Wwise and give you a bit of an overview of the routing situation we have and how we've set the containers out. So we have a dedicated bus for all character-related sounds. So within the character demo work unit we've created, underneath the actor mixer here, you can see that we've got an output bus set for character. If I click here just to list all of them out, you can see that we've got a couple of other ones that we'll be revisiting further along for some of the other mechanics we're looking at. It just helps us group all the relevant sounds through one channel, and then we can monitor that separately from the other projects that we'll be looking at. So the first thing we're looking at is the jump event. So you can see here we have a jump random container, and we've loaded several audio files underneath it. So I've got 4 separate jump files. We can hear what they sound like. So what we've done here is add a little bit of pitch modulation as well. So if I jump back into the container itself, you can see that pitch here has just a little bit of modulation. If I double click on that, we can see it varies between minus 100 and 100 cents, and that just gives it a bit of variation and sort of make sure that we don't hear the same sound exactly the same over and over again. So that's the jump sound. It's fairly basic. We've got a modulator on here to make sure that we shuffle and don't play the exact same sound that we've played before. So that, in conjunction with the fact of modulating the pitch a little bit, does keep a bit of repetition in the jump sound, although we're normally in typical gameplay you don't hear that sound over and over again, certainly not in the demo that you'll see that we're using. So moving on from the jumps, we've also got another container for footsteps. This time it's a switch container, and underneath the switch container we have a series of random containers. For each of these each of these random containers, again, we've got a few variations of a single sound. So in this case, I've got around, from the looks of it, 9 different footstep sounds. So let's give you an idea of those if I go through them. Fairly basic sounds, very similar in how they are. So for each category, we loop round. Again, we've got something in place to make sure that we avoid the last few sounds that were played. So in this case here, we've got play type set to random, standard, and avoid playing the last one played. Again, we have put a bit of pitch modulation in. Rather than doing it at the random container level, we're doing it above at the switch container level. So that way we don't have to set it individually for each one of these random containers we've got for dirt, grass, gravel, and wood and solid. We can just do it straight away by doing it on the switch container. Repetition is a bit more noticeable within footstep sounds, just based on the very nature of how commonly they're played during a typical game session. So that's why, rather than having 10 different jump sounds and just 2 footstep sounds, that's why we have a lot more from a footstep point of view. You can see for each one of the categories we've got around 10 different files. So moving out of the actual audio side of things in the Project Explorer, if I go over to Game Syncs, you can see we have a switch named Footstep Material. If I click on this, you can see that we have actual material switches that match the material audio containers. So they're used to dictate which random container to play the footsteps sounds from within the main switch group. So if we look at the actual footsteps container again, we can see here, this is where we're defining the switch group that we're using. The default switch is grass. So if no switch is sent over from Unity, then this is the default one that it will use. But you can see if I go into each of the actual assigned objects here, the gravel container is assigned to the gravel switch, the dirt switch is assigned to the dirt container, and so on and so forth. So essentially, this is how we set up a basic switch group. And one thing we could do within Wwise, if I click on the footsteps group and start to play sounds, that'll play it for dirt. And if I switch and set it to gravel, it'll start to play it from the gravel container. Same for wood, and so on and so forth. The third area we want to look at is how we go ahead and set a modifier for crouching, and we do this again under game syncs. Rather than it being a switch, we go for states, and you can see we have one here for crouch state, and within that state group we have one for crouched and one for not crouched. So obviously it's used to modulate the sound between whether the player is crouching or not. State group is probably a more appropriate option for dictating when the player's crouching than a switch group. And that's because although switch groups allow us to switch between separate containers, you can remember within the footstep group we were looking at different random containers within footsteps. A state group actually allows us to modulate the volume, affect pitch, and filter higher frequencies when the player is crouched. So if I jump back to the footsteps container again, and under the states tab, you can see here that we have one for crouch state in terms of crouched and not crouched. And you can see that when we're crouched, what we're doing is we're dropping the sound of the footsteps by about 10 dB. We're dropping the pitch, and we're putting a bit of a low pass filter on there. So again, using just the using Wwise to mirror what it will sound like in the game, I'm going to switch this back to grass. We can hear our grass footsteps there. Now if I go to state, set the crouch state to crouched, it's much muted, it's much slower. And again, I can go back into the switches, switch that back to gravel, and hear what gravel would sound like when we're crouched versus when we're not. The only other thing to look at within the footstep project that we would need in terms of Unity being able to post instructions to Wwise to actually play these sounds is to events for those sounds. So if I go into the event side of things, you can see under another work unit I've created for 4 character events. We have one for jump and one for footsteps, and all that literally does is just sends an instruction to play the jump random container, and under footstep it just plays the footstep switch container and the subsequent random container underneath that. So that footstep and jump are the name of the events that we'll need to post back from within Unity. Finally, as per the previous videos, we're going to set a sound bank up for the character and all the relevant files under the work unit. So if I go from layout to the sound bank layout, you see we've got one set up for everything here. Under character, all I've done is drag the full character demo work unit over to the soundbank editor and made sure that in the events, the structures and the media are all included. So providing that the file paths are set up correctly and the integration package has been installed correctly into Unity as per the previous videos, we now have a workflow for creating and modifying sound assets in both Wwise and Unity. So all we'd need to do is go ahead, I'll untick all of them and just do character in this case, go ahead and hit generate. You can see that working away, and that's done. So that's really it for the setup in Wwise. What we'll do now is jump over onto Unity and show how we get our game to actually post the events and the modifiers and game parameters back into Wwise. So here we are in Unity, and to start, we've simply imported the standard third-person controller prefab. So I've gone ahead and imported that using assets, import package, characters. You might remember from my initial video that we are going to be making changes to the scripts or adding additional scripts within within that prefab. You need to make sure that you move it out of the standard assets folder. This is where it would be placed by default, and up into the root level folder, which is where it is here instead. So if you see under characters, you'll have a third person character, under that a prefab folder, and then 2 prefabs. So all we're using is this third person controller. We've got one here already that we've made changes to, but let me drag a new one in just to show what you'd expect to see within a new one that's been imported. So you can see down here in the inspector, we've got an animator, rigid body, capsule collider, and then a couple of custom scripts that have been written as per Unity's development. So one for user control and one for the character itself. So what we've done is exactly the same thing. Let me get rid of this one, jump over onto the one we've created. You can see it's very similar, all the same things, user control, character, but then there's 3 additional components. We've got an AK game object script one here, and this one essentially is used to register the object and update its position every frame. The second one we have is AK bank. That's used to load in the relevant sound bank. That's very important because without it, Wwise won't be able to load the relevant files and the events into memory. The third one and the most important one is the third person sounds script. And this is essentially to hold all the new Wwise functions. So that being the case, let's dive directly into that script there. So that's gone ahead and loaded up in the Mono Develop editor. We've got all the standard Unity and C# stuff. I'm not going to go too much into detail on class and mono behavior. If scripts are fairly new to you, I'll post a couple of links at this point to the to some of the basics and tutorial videos that Unity have put out on there. But just to run you through what's happening here, we've got our animator variable that we're initializing as m animator. So what this does is just makes a reference to the animator component that's already loaded against the third person controller, and then that lets us within this script actually look at what that animator component is doing and pull a few variables from that. So that's what we'll see here. There's often times where we need to reference a specific component within the game object. Other times it might just be in the form of a global variable or some other value. But it helps to have a standard naming convention. That's why we're using this M here and using that approach to reference these external sources, especially when you're initializing it. So that's what we're doing here in terms of initializing the animator. And then we move over to the core update function. So we're using a Boolean that exists within the third person character animator component known as crouch, and that ultimately just checks the crouch state of the character, and we post this result back to our crouch state group in Wwise. So you can see here we have a line of code called akSoundEngine.setState. So just to give you an idea of the format that and the context that we're using here. Firstly, we have the set state command itself. Then the first value that we pass in is the name of the state group itself, so crouch state, and then the second is the state itself that we're referencing, which is crouched. So it's a very basic function here. If crouch as a Boolean is activated, then we need to set the state within Wwise as crouched, or else we set it to not crouched. And it's very basic. Ultimately, the C button on your keyboard by default controls whether the player is crouched or not. So ultimately, when they're crouched and the player's pressing C, that triggers the crouch Boolean within the animator, which ultimately every frame this script is checking to see if it's activated or not. So it's very, very basic from that side of things. But it's once you've got this up and running, you're well on your way to having your own custom demo put into place. So we then have 2 very basic one-line functions. We have one called footstep play and one called jump play. The jump play is made as a public variable, and you'll see why that is the case. All these do is use another command from the AK Sound Engine library, which is just provided as part of the Wwise integration, and this is your post event function. You use this over and over again. It's a very common request to use. So the format here is again the post event function itself, the name of the event as it exists in Wwise, so footstep and jump as we saw earlier on, and then the registered game object that is calling in this event. So in most cases, and certainly in this case, we're leaving that as game object. and that references the object that the script is attached to. So let's go ahead and see how we actually get Unity to call these individual functions. We know that they're going to post that event back, but how do we actually tell Unity when to activate this function and then post that event? So it's done in two key ways. Footstep play is referenced by an animator event within the humanoid run animation, and that simply posts the event back. So if we come out the script within the third person controller, when that's selected and we go into animation, we've got a number of different animation cycles, and by default the one we were using was humanoid run. You can see all the other ones were named as read only. So the humanoid run one was initially read only, and what we had to go ahead and do was create a copy of this and make a read and write version, and then we rename that to audio. So the actual animation states themselves, they exist under third person character animation, and you can see you've got all of the individual areas, all the individual cycles here. That copy we've then called humanoid run audio, and then we've re-imported that into the animator and used that one rather than the default humanoid run. So if I go to humanoid run audio, the key line that we want to look at, we can ignore a lot of this. This essentially just defines the way that the animation works. So if I move over slightly so we can see this at a better angle. Go back to humanoid run audio. Yeah, it just defines the actual movement itself. That, but the key bits that we're looking at in terms of actually posting references back to the script itself are these individual footstep play events that we've posted. So all you need to do to create a reference back to the sound script is right click, add animation event, and then within the functions you'll have a drop down of all the individual functions that you can use. So there's a couple of different ones, but you'll be able to see the footstep play and jump play, and it's literally just a case of selecting that. So if we do a footstep play, close that, and straight away whenever we activate this cycle in the game itself, I've certainly tried to link it as closely as possible. It's a bit difficult here because he's in midair, but that is the point there in that frame. And moving on in this frame here, it's hard to see because the angle, where the foot makes contact with the floor, and that's where we want to play that footstep animation. So that's how we actually post the footsteps themselves, and we'll see in the game environment in a second how that actually translates and straight into the Wwise API. I'll go ahead and delete that animation event for now. Jump play is referenced by the core third person character script. So let's come out of the animator now, go back into the player, player component itself, and if I go down to third person character script, double click on it, open that up in mono develop. You remember earlier I was saying that we need to move, this is exactly why we need to move this asset up into the root level, because this is where we're making a direct change to the default script. So the key change that we've made is here, where we've referenced third person sounds, and we've initialized that, as we have everything else, as Wwise. That's where we create the variable. We then initialize it here, get component third person sounds, which we can see third person sounds is attached to that component. So that's loaded in, and all of the public variables and functions are now accessible through this script here. If I go ahead and find in the page itself the reference to Wwise, so we've got the initial declaration, the initialization, and then further down, this is where we've simply just added an extra line into the jump command. So all of this is how Unity actually moves the player. Obviously we're not looking at that side ourselves, we're looking at just the audio. So all we need to do is just add that additional Wwise.jump play, which we can find as a function. And that's it really. That posts the jump sound effect directly back to the to Wwise, so that whenever a jump is available to happen, so to speak, and it occurs, then we hear that jump sound. So that's it for the for our custom script and the editing of the pre-created script as well. It's not particularly complicated compared to the vehicles, which we'll look at later, and the work's handled mostly by the animator and the third-person character script, and then back within Wwise itself. But we now have a functioning character model with audio for footsteps, and that can be modified by the character's crouch state as well. So let's actually look what that looks like in the game environment itself. And you can see we're triggering the footstep sound every single time we hit the that specific frame within the run animation. If we try crouching, footsteps are there, but they're much more muted. They're much further down in the mix. And if we go ahead and jump, we can hear that jump sound effect. So that's what we put into practice so far. The last thing we need to do is update the footstep material switch group based on the surface the player is standing on. And we do that by passing the value back into Wwise by creating box collider triggers and then detecting when the player enters these areas. So if we look at the existing scene, underneath the Wwise objects category, we see footstep zones. I'm just going to zoom out of this so that we get a much broader idea of where the footstep zones actually are. And you can see there's quite a few different ones. So we have 4 types of zones: wood, gravel, grass, and dirt. And you can see them highlight themselves as wireframes as we go through them. You can get an idea where they've been created. But essentially, it's just a series of individual 3D boxes that overlap. So in the case of dirt, these are the ones that overlap with the dirt material. So that's anywhere with this sort of sandy color or this dark brown track itself we're representing with dirt, and that's the sound that we want to hear when the player crosses that terrain. So the idea is that when the player enters these areas, we know that the footstep sounds represent the texture they're moving on. So the actual way these boxes are created is very, very simple. Let's create one now as an example. If I go to game object, create 3D object, and then go ahead and create a cube. So we've got a small cube here. You can see at this point it still doesn't look anything like what we need it to. So under the box collider component that comes with it, we want to make sure that is trigger is set to true. That removes the rigid physical element of the object and it allows the player to clip straight through to it. We can also just turn the mesh renderer off. We don't need our collider to be visible at all. And next we use the Wwise picker down here to actually drag the relevant dirt switch onto the component itself, like that. So this is where the drag and drop functionality really comes into its own. You can see we haven't had to type a line of code yet to do this. It's very simple. Just go ahead and drag that on instead. One thing we do need to do is change the trigger on and when this is set. So we want the switch to trigger when another object, in case the player, in this case the player, enters that area, not at the start of the scene, which is how it's currently set. So we need to go ahead and deselect start. That'll set it to nothing, and then go ahead and select AK trigger enter. There we go. It'll then also ask whether we need to use other object. Yes, we do, because it needs to be the player that triggers that. That signifies that the character model is the catalyst for this event. We then just move the object around. You can scale it like that. You can go ahead and use the scale tool like this. And essentially, you just need to set it up in place so that it covers the area of ground that you want to reflect that sound. I did find a quick trick for the wood sound, because the wood sound is reflected ultimately by these black boxes over here. So rather than try and map one by one every single zone as I did just then with the dirt side of things, you can actually just create a copy of the whole structure and then set the properties accordingly. So if you go ahead and look at the wood zones, you can see they pretty much look like a carbon copy of the structure itself, and that's because it is. What we do is we take the structure, make a copy of it, and then all I've done is shift the whole thing slightly up the y-axis, and you now have a like-for-like set of trigger zones with much more minimum effort. So anywhere that you're using a structure as the terrain or as part of the object that the character's going to be walking on, this is a much quicker way of doing it. So that being the case, let's look at what it looks like in the game itself. Now we have trigger zones enabled too. So there's our standard dirt trigger. Now as I go up the wood, you can hear that that's changed. Jump down there, back onto dirt, grass. Dirt, and then back to gravel again. Brilliant. I'm going to go ahead and load up the profiler as well, actually, because one of the key things that is great to learn from is to actually see what Wwise is doing in the background. We can hear it's working, but how do we know that it's working in the way we actually want it to from a back-end point of view? That's why we use the profiler. So I'm going to go ahead and get that loaded up for us now. So now we've got the profiler running. What we're able to do is actually recreate what we were doing earlier, going in between different terrains and jumping and crouching and seeing how that registers within Wwise. So you can see here this capture here. You can see that we're capturing already. So I've linked Wwise over onto the Unity project, and that's running now in the background. And you'll see if I start to move, you see these individual footsteps coming up. Dirt FS2, FS1, FS3. So you can see it's randomly choosing what footsteps we want to actually pick. But then if I start to cross over onto different terrains, on the left hand side where you've got the footstep material switch, you can see it's telling us that we're switching to dirt, switching back to gravel, switching to dirt again. If I went over here, now I'm switching to grass. And you can see ultimately when I'm on grass, now we're getting grass FS3, 4, 7, 8. You can see all the different grass footsteps coming up. If I hit jump, you can see that plays very briefly. You can see that jump. You see that when I do it this time, it plays jump 3. When I do it this time, it plays jump 1. So it's randomly going through all of those again. And also if I crouch, you see it's still playing the footsteps, but now there's a minus 10 dB modulation occurring in the background there. So the profilers are a great bit of kit, and we'll come back to it over and over again at the end of every mechanic just to see what actually is going on in the background. But in this case, it looks like it's working exactly as we intend it to. So that being the case, let's draw this video to a close. I hope that's been helpful and gives you guys a bit of a leg up in terms of getting this sort of thing off the ground yourself. Next video, we're going to be looking at creating ambiences. You might have heard a bit of them in the background in this video. So join us next time and we'll go into that in a bit more detail. Thanks for now.